It's always buggy. So that's why I refuse to use the playgrounds, and I would use a project. And so essentially, we would just call our method of parsing the JSON in the view.load. So every time the initial view controller pops up in our simulator, the JSON will be returned back to us in the console. So, but the project, we actually have to configure this setting in our info plist due to us actually incorporating HTTP methods and requests and all that good stuff. So what you do is you go to your info plist, you go to information property list, you access the app transport security settings, click on this arrow pointing down, allow arbitrary loads, and change the value of that to yes. Now that's that saved, just Command S to save the file, and we could go to the view controller. So, like I was saying, when we create the methods as well as how we're going to go about parsing JSON, we could call it in the view.load. Therefore, every time the view loads up in the simulator, it will return back to us in the console. So let's start this off. But before anything, actually, we have these API tester tools such as PAW, Postman, whatever you want to use, and we can test it on Postman. So, as you can see, I have this base URL, which ends at v2, and we specify the Pokemon we want. So say we want 12. I would put that in Postman and change the method to get out of all of these. See a post, put, patch, delete, each doing a different type of request. Post would send resources, put would edit, actually put would just send you resources, and so patch would fix resources. Yeah, put is like literally inserting resources, post is sending them. Yeah, all these deleting resources, pretty self-explanatory. Get, since we're fetching the resources. And so if we edit this end route to 12, or the endpoint to 12, and we send it, it's loading up the request, and the name of the 12th Pokemon in the whole JSON file is Butterfree. And we could change the numbers up again, just like I was showing in their tester tool online. For 34, we actually get one named Nidoking. So it's pretty good. And we could play around with this even more. Say instead of specifying a Pokemon, we just want all the Pokemon. We actually get all these: Bulbasaur, Ivysaur, Venusaur, Charmander, Charmeleon, Charizard, Squirtle, it's so on and so on. So actually, what we're going to be doing is how to implement this in our code instead of using these API testing tools. So first things first, let's have a class, and we would call it network. Just symbolic of the network request we're going to be making. And then we're going to access this singleton equals URL session dot shared. This is where all our network requests are going to be placed on this session, or using this session, synonymous to just having things in one session to keep it organized, as well as keep the networking traffic to a minimum. So once we have our session set up, we will have a GET request. So essentially what this does is, it's self-explanatory. We're going to have a request and we're fetching the resources, therefore we're getting them. So most people like to break this up into several lines of code, but however, on the flip side, I would rather have it shorter and more precise, so we can just make this one-liner. So we could say URL request, and we would have URL. It's going to be a type URL, and we're going to specify the URL. So we could take our Postman URL, we could copy that, and we could copy and paste that in this URL string. Now this serves as our URL for where we're going to be fetching the resources from. However, the compiler, or whatever ID you're using, which hopefully is Xcode, does not know that this GET request is actually fetching resources or is an actual GET request. So we actually specify it by saying, well, we take our GET request. We actually have to wrap this around in the function, and reason being is just so we could call it in our view.load when the time comes to. So we actually take our GET request, and we access this method called HTTP method, and we specify it to be a GET. Now, as you can see, as I showed you here, there are multiple HTTP methods that we could use, such as get, post, put, patch, delete, etc., etc. An easier way to construct these HTTP methods is to use an enum. Not only is it cleaner, it also gives you access to all these methods instead of having to implement it every single time. But for all intents and purposes, we're only fetching resources, therefore we know we're going to be using a get. But we could go over how to construct that enum at the end of this video, so stay tuned. So now that we have specified that this is actually a get request, or we're fetching resources by declaring that the HTTP method is get, we actually can construct the network request now. So we say session, that we take our URL session.shared, which is held in this let constant session, and we ask for the data task, complete this task with the given data, and for this data we are passing in the get request. And that makes sense because to pass into the data the get request, we are actually passing in this URL, and it's making a request to that URL. So it's going to populate that data with the resources we get back from that URL request. Now we can access this closure, fill in these necessary values, data response error. Okay, now we can say if let data, if we assign the data that's been populated by the URL request in this let constants data, we can actually take we're gonna create a new let constant called let Pokemon. We'll call it let Pokemon fetch. It's going to be try to serialize this data we're getting back. We can say JSON object with data, assign the data that's been populated with the request, and dot allow fragments. It's gonna give it to me. Yes. Okay, now essentially what this serialization does is when you're sending resources from the internet to whatever it may be, your server, from a server to a client or the internet to a client, the object being sent is formatted differently in a sense. So what serialization does is it takes this type A object and conforms it to in a format that type B could read. So say you have a server that's written in Python and your front end or your client is in Swift. Swift objects can't be read by Python objects and vice versa. Therefore, we have to have a format where it's an intermediate format that could be read by both ends. Therefore, when it gets there, it could be deserialized into an object that can be read. However, if it's not serialized or it's not formatted in this way that the point you're trying to go to can be read, it just can't do anything with that data. It's literally useless just because it cannot be read. So serializing is taking this object or this data that we're getting back from this URL request and constructing it or formatting it in a way that our app or compiler can read to return us that JSON data. And when it gets here, it takes that serialized object or that very formatted object and formats it in a way that Swift only could read. So it goes from a point where both ends can read it and takes it and formats it once again into a format that only Swift can read. If we're sending it back, it would take that serialized object or that formatted object that both ends can read, and say we're sending it to the server, which is written in Python. Once it has that intermediate format and it gets to the server, it would actually deserialize it or decode it from that formatted object and only to an object that Python could read, or a Python object. So it's just about finding that intermediate format that could be both by read ends and that could be read by both ends as well as be sent over the network. If it's not serialized, it cannot be sent over the network. A good way to actually think of it, now that I think about it, is say you're sending clothes to someone in a different country. You take that object being the clothes and you put it in a box. You can't just send clothes by itself over the airplane or through the airplane to wherever you're sending it to. You have to package it in some sense. So say we're sending an object from our Python server to our Swift client. We take these clothes, which represent the Python object, and we serialize it, which is essentially putting it into the box. Now the airplane ride from point A to point B would actually be the network flow. To even get it on the airplane, it has to be packaged in this box. Therefore, it has to be serialized. While it's on that airplane, no one's taking it out. It cannot be taken out of that box. Therefore, it stays in that format until it reaches its destination. Now, when it gets to point B, or it's still in the box, it's still serialized. when the person opens up that box and takes out the close, it's deserializing it or decoding it from that once boxed format or that once serialized format in only a way that the receiving end could use. See, when I say use, no one could use a box, but they can use what's inside, being the close, or the object that once was Python is now a Swift object. So that's essentially what serialization does. And to see that we're even getting back the JSON, we'll print our Pokemon fetch. And like I said, we have to call this in our view did load. So we could say let networking equal our network. We're making an instance of class network, and then we're going to access that by saying network. Now, if we run this on an iPhone 8 Plus or whatever model we want, we're not actually working with elements, so it doesn't really matter. Nor would it if you had, unless you're going for a constraints approach, which has no relevance to what we're doing right now. So as this is building, this is going to open up a simulator. And now we could see when this view loads. Yeah, just give this a minute. But yeah, if that serialization example doesn't make sense, I'd be happy to go over it in the comments. And yeah, so now that the view loaded, if we go to the console, we can actually see, yes, we made a mistake. To actually kick this network request off, and we actually have to put a method called .resume, and that just resumes it. It just starts it, essentially. So if we run it again, that's a pesky thing to forget. I can't tell you how many hours I've been stuck on this and just realized I forgot to use .resume. So as you can see, we get back all these Pokemon, right? Bulbasaur, Ivysaur, Venusaur, Name, Charmander, all these guys. That's because the reason we're not getting back, as we saw in Postman, if we specify which Pokemon we want, we could actually get back their name as well as their abilities, their stats. You know, we get all these attributes back. The reason being we didn't get that is because we didn't specify Pokemon. Therefore, our URL ends at Pokemon, so it's just grabbing back all the Pokemon from the JSON file. If we want to specify which Pokemon we want, we'll also get these list of attributes back. Now, so if we put 34 and we run this again, we will actually get back that specific Pokemon's attributes, as you will see when this JSON loads. See, now we don't need this side. We actually get back this whole object. See, it's very long. It goes really in depth on what that specific Pokemon contains or what the attributes for it. All of this. So as you can see, though, no, we're never really going to need all of these attributes. A lot of this stuff may be pointless for their uses of our apps. So in the next video, we're going to talk about how to actually model this data into a format that we would want and we're able to implement more efficiently. Such as, we don't really need the version group details. That's just very irrelevant. You know, we don't name red, blue. No one really needs that. I don't see the point in having that. So modeling will actually just allow us to specify what parts of these attributes we want, and we would be able to display it. So yeah, that's how you grab back the JSON. And before this video ends, we can actually, as I said earlier, we can construct a enum where it actually can iterate through different HTTP methods, and it's just a much cleaner way to tackle your APIs, whether it's conforming to a post request or a get request or a put or patch request, delete request, whatever it may be. You're just able to do this. So if we access our class here, we could have an enum called HTTP methods. It's essentially going to have a case get, and it's going to be, so our case statements can be whatever you may want them to be called, but since it's actually syntax heavy on the request, as you can see in PAW, if you notice, all our types of HTTP methods are all caps lock. So it's good to never come out of naming conventions. Keep your variables, your case statements, lowercase, and just set it equal to a hard-coded string value so it knows that we're actually tackling a get request, and we'll go over why it knows to do that. So we have different ones. We could It's an error from string or be of type string. Now we have case post